All right, in this video, we're going to be going over some review on radicals. So to start, we're going to be looking at square roots. We want to just go over some vocabulary here. So as we look at the first statement here, it says when you square a number, which means you're multiplying it by itself, what you get is called a perfect square. So an example of this is listed down below. We have 5 squared. Now, what is this? What is it when we square a number? What we're saying is squaring a number just means you're multiplying it by itself 2 times. So this 5 squared would be 5 times 5, which we understand is 25. And what we understand here then is that this means 25 is a perfect square, right? So off to the right here, we're being asked, what are some other examples of perfect squares? Well, we can think of things like 4. 4 is a perfect square because this is coming from 2 times 2, which that's 2 squared. If we're looking at another one, we can think of 9. 9 is a perfect square because it's the result of 3 times 3, or 3 squared. So we have several perfect squares that we're going to look at throughout this course. And moving on, now that we have a general idea of what a perfect square is, let's talk about what the opposite of that would be. So the opposite of squaring a number would be the inverse operation, which is called finding the square root. Right? So when we're looking at the square root of a number, what we're really trying to find here is the factor that is multiplied by itself to get to that number. So off to the right here, we have an example, right? Looking at what we saw earlier, but in the reverse direction. The square root of 25 is 5 because 5 times 5, well, that's equal to 25. So again, when you're square rooting a number, we're just looking for what number multiplied by itself gives us that amount. And when we're talking about the square root of 25, this is when we have that symbol, that radical there, and we put the 25 underneath. So that's what it means to square root of a number. The square root of a number, again, is just finding out what number times itself gives us that amount. So let's go ahead and look at some examples. In the examples listed below here, we're just going to be looking at both of the items that we talked about here in the first part of this video, which we're looking at 3 squared. We understand that that just means 3 times 3, which earlier we said, well, hey, that was 9. So 3 squared is 9. If we look at the square root of 100, remember we're talking about taking the square root of a number means what number times itself gives us 100. Well, that's going to be 10. So the square root of 100 is 10. If we look at 8 squared, well, 8 squared is just 8 times 8, which gives us 64. So 8 squared is 64. And then if we look at the square root of 36, now we're looking at a square root. Remember, what number times itself gives us 36? Well, the answer to that is 6. Now, we run into a situation like we have down here where it says, now try this one. If we try to take the square root of 72, what ends up happening is that you can try to find a number times itself to give us a square root of 72, and it's not going to be a whole number. So I have a calculator right here, and we can actually check. If we were to take the square root of 72, you end up with a really long decimal, right? And this decimal actually goes on infinitely. So in this class, we don't want to be rounding decimals here. We want to be looking at, well, we want exact answers. What exactly is the square root of 72? So right now, we currently can't do this, but we are going to look at how do we find that exact value by completing a process known as simplifying the radical, right? So when a square root's not a perfect square, for example, 72, we go through a process called simplifying the radical, which we're going to see in the second part of today's notes.